Hello everyone, the Space Channel is with you. Everyone knows that the Earth's atmosphere and magnetic field protect us from deadly cosmic radiation. But there is no such protection in space. Also, due to the effects of Earth's magnetic field, in some areas near our planet the amount of radiation is much higher than, say, on the surface of the Moon. But, despite this, American astronauts visited the Moon half a century ago and returned unscathed. How is that possible? Let's figure it out. There are two types of cosmic radiation. The galactic radiation, which is particles that come from outside the solar system, and solar radiation, which consists mostly of protons emitted by the Sun. This flow of protons is often called the solar wind. Galactic rays are usually of very high energy and easily penetrate the Earth's magnetic field. When they reach the planet's atmosphere, it absorbs most of them, protecting us from serious exposure. Most solar wind particles cannot break through the magnetic field, because they are too slow. All particles that do not break through the magnetic field are rotated by it around the planet. Due to that, the Earth is surrounded by radiation belts called the Van Allen belts. Which belt a particle will fall into depends on its charge, mass and energy when it hits the Earth's magnetic field. At first view, the belts have a shape of a toroid. The inner belt has a maximum density at an altitude of about 4,000 km, and the outer one at the altitude of about 17,000 km. Also, they are inclined to axis of rotation of the Earth, and have a very complex structure. In different places of the same latitude, they are sometimes closer and sometimes further from the surface of the Earth. In addition, the shape and density of the belts depend on solar activity and even human activity, due to which their configuration is constantly changing. However, a safe zone of about 6,000 km wide always exists between the inner and outer belts. The level of radiation in the Van Allen belts is indeed high, but not as high as the lunar conspiracists like to paint it. If you send a person without protection to fly directly into the belt, they will receive a dangerous dose of 1 sievert in a few days, and a lethal dose of 5 sievert in a couple of weeks of flight. Obviously, the exact time depends on the specific orbit and the activity of the Sun, but a dangerous dose couldn't be delivered in just one day. To minimize the effect of radiation in the belts, the flight paths of all Apollos except the 14th bypassed the inner radiation belt and crossed only the outer one, and in the thinnest regions, and at the maximum possible speed. For astronauts flying to the Moon, crossing the Van Allen belts took a matter of hours, about 3.5 hours on the way to the Moon and about 2.5 hours on the way back. However, in order to reach the Moon and return home safely, the astronauts of Apollo mission not only had to cross the Van Allen belts twice, but also had to overcome a huge distance from the Earth to the Moon. Such a flight usually took about 3 days each way. The astronauts had to work in orbit and on the surface of the Moon for several days. The total time of missions was from 8 to 12 days for various flights. Thus, the Apollo crews were exposed to radiation for quite a long time. Why did it harm them? The fact is that the astronauts had protection against radiation. Of course, the entire ship couldn't be sheathed with the thick layer of metal, otherwise it would be too heavy. But it was quite possible to protect those parts of the ship where the astronauts were. The Apollos had radiation protection in the form of 25 mm of aluminium. Also, the command module, where the astronauts were mainly located, was additionally protected by steel with a thickness from 18 to 69 mm. In the event of a flare on the Sun and a sharp jump in the level of radiation, the astronauts had to hide in the command module. Thanks to this, the dose absorbed by astronauts, depending on the mission, varied from 1.6 to 11.4 millisieverts. This is significantly less than the standard dose of 50 millisieverts per year, established as the norm for people working with radiation on Earth, and which is considered safe. Even the astronauts who received the highest doses, about 11.4 millisieverts during the flight to the Moon, after living a year on Earth in ordinary life, wouldn't even come close to 50 millisieverts. Therefore, crossing the Van Allen belt is completely safe, and even a flight to the Moon and back wouldn't cause much damage to the body in terms of radiation. Well, that's all I have. Don't stay alone in Van Allen belts. Better, stand with Ukraine.